The reason that probability is so important is that it helps us to make predictions. The past tends to predict the future. You can use patterns from the past to determine how likely something is to happen in the future. For example, I have a series of players here who've been playing a game, and how many points they've scored in the past. We can use this data to make predictions about what will happen next. Now my first thing I wonder is anything impossible based on this chart? Well, I can see all of these players have scored at least a couple of points. So I could predict that they're probably going to be able to score some points in the future. Something that might be impossible would be a person who's not in the game to suddenly win the game with points. So there is no player 99, therefore it would be impossible for player 99 to win. They're not part of the game, they don't have any points, it's impossible for them to win. It's more likely that I can find something that's unlikely, or easier for me to find something that's unlikely. For example, player 34 doesn't seem to be doing very well. They only have 1 point. So it is unlikely that player 34 will win the next 10 points and win the game. It would also be unlikely for player 42 to suddenly lose the game. They have the most points. Chances are good they're going to win. Now, I'm not saying it's impossible for them to win. I'm just saying, or impossible for them to lose. I'm saying it's unlikely that they would lose. Is there anything that's certain in this game? Well, looking at my data, I can't be 100% positive about anything. There is always a chance that someone would drop out of the game or not do well, or someone could suddenly get better. So I can't really say that anything is absolutely certain in this game. Last but not least, I could analyze it for who is most likely to score the next point. Well, both player 42 and 35 seem to be doing very well. They have the most points out of anyone, so I could say it's most likely that they are going to score the next point. Notice it's easier for you to find things that are unlikely or likely. It's challenging for you to find something that's impossible or certain because those were the things that were furthest on our spectrum of probability, and really most things are considered either likely or unlikely. Can you find something in here that would be likely to happen? What would be something that's unlikely to happen? We can use probability to make guesses about things that aren't as well known. For example, if I have a bag that has 5 little cubes inside of it, I can make some random draws, and each time I draw a dice or a cube out, I can put it back in the bag and make some predictions about what are the total cubes inside of that bag. So when I did this experiment, I had 5 reds that came out, 10 draws that were blue, and 10 draws that were green. I had no draws that were yellow. There's a process for figuring out what color the cubes are that are inside that bag. The first thing I want to do is figure out how many draws that I had, the total occurrences. So 5 plus 10 plus 10 is 25 draws. So I did 25 draws out of the bag, and each time I put the one back in. Then I drew again and put it back in. Drew again, put it back in. I did that for 25 times. Now I want to take those number of draws, and I want to divide it by the number of cubes in there. I could feel with my hand that there was 5 cubes. What I'm trying to figure out is how many times each cube should be drawn out in a perfect world. So if I had 25 draws and 5 cubes, 25 divided by 5 would mean each one of these cubes should be picked out of the bag about 5 times if everything is fair. Because 5 plus 5 plus 5 plus 5 plus 5, or 5, 10, 15, 20 equals 25. Now that I know about how many times each cube should be drawn, I need to figure out about how many cubes match up with these totals. So I said each cube is worth 5. I noticed that red got drawn out 5 times, so I would predict that there is 1 cube that is red. Blue got drawn out 10 times, so I want to skip count by 5s to get up to 10. 5 plus 5 equals 10, so that would equal 2 cubes that were blue, because 5 plus 5 equals 10. Now yellow never once got drawn out. That makes me think that it's probably impossible for me to draw yellow, probably because there is no yellow cube in the bag. Last but not least, I have green. I want to skip count by 5s to try to get up to 10. 5 plus 5 equals 10. That would be 2 cubes that were green. And look how it works out perfectly that all of my cubes have been spoken for. Now let's make sure that the patterns hold up. I should see that blue and green have the most cubes because they had the most draws. Both blue and green have the most cubes. I should see that blue and green should have about the same number of cubes because they got drawn about the same number of times. Both of them have 2 cubes, so that holds as well. Last but not least, I should see that red should have about half as many cubes as blue because it has half as many draws as blue. Red has 1, blue has 2, so that's half as many as blue. All of my patterns hold up. I can feel confident that there is 1 red, 2 blue, and 2 green cubes within my bag. help me to figure out how many cubes or what color are the cubes in this bag. Remember, the first step is I want to figure out how many draws were made. I'm going to add up all my numbers. What is 10 plus 5 plus 5 plus 5? If you said 25, you'd be correct. Now I want to figure out, in a perfect world, how many times each cube should have been drawn out in order to get 25 draws. So I'm going to take 25 divided by 1, 2, 3, 4, 5. What is 25 divided by 5? Well, that was just like the last time. Each one should be drawn out 5 times. 5, 10, 15, 20, 25 draws. Now I need to skip count and figure out about how many cubes would match up with each one of these totals. How many blues, yellows, and greens do you have? You should have noticed that all blues, yellows, and greens were each drawn 5 times, and we said each cube was worth 5 draws, so I would expect there to be 1 blue, 1 yellow, and 1 green. Now let's tackle that red. This time there was 10 draws of red. What does that mean for how many cubes there should be? You should have said that there should be 2 red cubes, because we know that 5 plus 5 would equal 10 draws. Now let's make sure our patterns hold up. Blue, yellow, and green should have about the same number of cubes because they each have the same number of draws. Well, each one has 1 cube, so that works out just fine. Red has more than any other color, so I should have more red cubes than anything else. I can see that I have more red cubes than any other color, so we're good to go. Last but not least, I should see that if I double yellow, I should have red. So if I doubled the yellow and had 2 yellows, I should have the same as red, which is true. All of my patterns hold. I'm ready to move on to my next example. This time I want you to figure it out on your own. Think about the process of adding up the total number of draws, and then sharing to figure out how many times each cube should be drawn out. Then skip count and figure out how many of each color would fall into each one of these cubes. Double check to make sure the patterns you see in the draws match the pattern you see in the cubes. Go ahead and pause the movie now so that you can do your math and figure out how many reds, blues, yellows, and greens would be inside that bag. First thing you should have done was figure out how many draws there were. 20 plus 30 is 50. This time the person drew out 50 cubes and put them back each time. Now I want to take my cubes and divide it by, 50 divided by the number of cubes. So I still have 5 cubes, but this time it's 50 draws. So each cube should be worth 10, because 10, 20, 30, 40, 50 would get up to 50 draws. Now I need to analyze my results. Both blue and green never once got drawn out of the bag, which makes me think it's probably impossible to get blue and green. That means all my cubes are going to be red or yellow. I notice that there's more yellow than red, so I would expect there to be more yellow cubes than red. Last but not least, I can count by tens to figure out exactly how many cubes. With red, I would have 10 plus 10 equals 20. So I would guess that I should have 2 red cubes. With yellow, if 10 plus 10 plus 10 equals 30, so there should be 3 groups of 10, 10, 20, 30, to get me up to 30 draws. I notice that I have that same pattern of more yellows than red in my cubes, more yellows than red, and I've used up all of my cubes with none of them being blue and none of them being green. So you can see how you can use the results to make predictions about what the situation was. If you know the situation, you can also make predictions about the results. We use that same process that we did before. So this time I know that I'm going to draw it out 50 times. I want to guess about how many times I get red, how many times I get blue, how many times I get yellow, and how many times I get green. The first thing that I notice is that in my cubes I have no blues, so there would be no chance that I could ever get a blue. I should get 0 blue draws. I also notice there's no yellows, therefore I will never ever be able to get a yellow draw. Both of them should have zeros. Now I just need to figure out exactly how many reds and exactly how many greens. I would expect that my number for reds is bigger than greens because there's more red, it's more likely, and fewer greens, so it's less likely. I'm going to take my 50 draws and divide it over the cubes to figure out about how many times each cube should get pulled out in a perfect world. Well, since I have 5, 50 divided by 5 is 10, because 10, 20, 30, 40, 50 gets me up to my total of 50. That means each cube should be worth about 10 draws. So since I only have 1 green, I would expect that it gets drawn out about 10 times. I have 4 reds, so 10 plus 10 plus 10 plus 10 would be 10, 20, 30, 40 times. I double check my work and make sure that they end up adding up to a total of 50. 40 plus 10 gives me 50. I can see that reds happened more often than green. I feel confident that this would be a good prediction or estimate of how many times I would draw out each cube if I were to draw them out 50 times and then put them back after each draw. This time, why don't you give it a shot? Notice this time I'm only doing 10 draws. Think about how many times each cube should get drawn out in a perfect world if I only took them out 10 times and put them back after each time. Go ahead and pause the movie now to make your predictions. One thing you should have noticed from this set of data is that all of my colors are there. I have blues, I have reds, I have yellows, and I have greens. So all of them should get drawn at least a couple times. I also noticed that I have more blues than anything else. It's more likely to get blue than the other colors. So when I have my prediction, blue should get the most. I have a total of 10 draws and 5 cubes. So that means each cube should get drawn 2 times. 2 plus 2 plus 2 plus 2 plus 2 should equal 10. 2, 4, 6, 8, 10? Yep, that worked out perfectly. That means each cube should get drawn out about 2 times. So this red cube here should be drawn out 2 times. Since there's only one red cube, I would expect that it should be drawn out about 2 times. Same goes for yellow. There's only one yellow cube. We said each cube is worth 2, so I would expect it gets drawn out 2 times. Last but not least, green is the same way as well. There's only one cube. We said each cube is worth 2, so it should get drawn out about 2 times. It makes sense that all of these are 2s because they have the same number of cubes, so they would have the same probability of happening. Each one would have a probability of happening 2 times if I draw out 10 times. Now blue is different because there's 2 cubes. That means it's 2 plus 2, which would be 4 draws. Notice my patterns hold up in the fact that blue should happen more than any other cube, and it should happen twice as many times as any other cubes because there's 2 of the blues on only 1 of every other color. Now the same pattern can hold when I'm doing it with spinners. I can use the same process even though it's with a spinner now instead of drawing things out of a bag. Notice here that my prediction didn't happen exactly perfectly. I had it and I figured out how many draws I had. 24 plus 24 plus 52 means I spun that spinner 100 times. I would expect that each one of these sections should get landed on about 25 times because 25 plus 25 plus 25 plus 25, just like 4 quarters, would be 100. Now it didn't work out perfectly, but like we said before, life isn't perfect. It doesn't always happen exactly like you predict. Now that I know that each section should be worth about 25 spins, I can figure out what colors were on the spinner. Notice yellow never happened at all, which would make me predict that yellow probably isn't a part of my spinner. I see that red and blue both happened about the same number of times, and they're both pretty close to 25. Since each section of my spinner is worth 25, I would expect that red happened 1 time, and blue happened 1 time. Now my last color that I have to play with is green, and I can see that green happened more than any other time. It happened 52 times. Well, if each one of my spinners is worth 25, 25 plus 25 would give me about 50 spins. I can see green happen twice, or 52 times, which would be about 2 sections of the spinner, because 25 plus 25 would give me a total of 50. Now I double check to make sure that my spinner matches what I said happened in my outcomes. Red and blue should be equal. Yep, red and blue are equal. Green should have the most. Green has the most. I can see that if I add together red and blue, I have about the same as green. If I add together red and blue, I have about the same as green. So I know that my predictions equal out to what happened with my actual spins. Can you predict how many times I should land on each one of these spinner sections? This time, notice I only have 20 spins. Think about how many times it should land on each section. Well, you know the process should be 20 divided by 4 since there's 4 sections. If you're not comfortable taking 20 divided by 4, you could always guess. Maybe you think it's going to land on 3 times each one. That would be 3 plus 3 plus 3 plus 3, or 3, 6, 9, 12. That's not enough. Maybe 4 then. 4 plus 4 plus 4 plus 4 would be 4, 8, 12, 16. Getting closer, but still not enough. Let's try 5. 5 plus 5 plus 5 plus 5, 5, 10, 15, 20. That's what we wanted, was 20 spins. So I know that each section should get landed on about 5 times. Now look at our colors. Notice one of our colors is absent. So what does that mean for red? If you said that red should never have any spins, then you'd be correct, so I'd get to put a 0 there. What do you notice about blue compared to yellow and green? You should see that it's more likely to land on blue than yellow or green since it takes up more of the spinner. So I'd expect that my blue spin should be more than yellow or green. What do you notice about yellow and green? You should see that yellow and green are equally likely of happening. If we know that each one of the sections is worth 5, how many times do you think if a spinner should land on green? Well, since it only takes up one section, I would expect that it would land on green 5 times. What about yellow? Again, it has one section, so we should expect that it lands on it 5 times. We said that blue is more likely to happen than yellow and green. In fact, it's twice as likely to happen as green because it has 2 sections and green only has 1 section. Since it's twice as likely, I would take green and I would double it. Doubling green, 5 plus 5, should give me a total of 10 spins. That also matches with our spinner because we said each section is worth 5. So this would be 5 plus another 5 would give me 10. Now I double check to make sure my math ends up with a total of 20 spins. 0 plus 10 plus 5 plus 5 gives me a total of 20 spins, so I feel confident that I've predicted the result as well as I can. Now it may not be perfect when I spin, but it should be pretty close with blue happening more often than yellow and green yellow-green should be pretty close to the same number of spins. Now you should have a pretty good understanding of probability. Go ahead and move on to some of the activities to practice the skills yourselves.